quiet engine pulled the train. If the query is engine, which earlier token should matter most? Before you answer, this is a synthetic toy model, not a measurement from a deployed transformer. The toy sequence contains 6 tokens. Each token has a numerical representation, but the query does not simply copy every neighbor equally. It asks a narrower question: which token representations are most compatible with what engine is seeking here? Hold your prediction while the possible links appear. Maybe proximity wins. Maybe the action word wins. Or maybe the descriptive word quiet creates the strongest relationship. The important surprise is that attention begins with comparisons, not with a conscious spotlight moving over words. The query token is engine. For this operation, every token supplies a key that can be compared with the query and a value that can contribute information. Think of the query as a request, each key as a description of what is available, and each value as the information that can be mixed. Those are mathematical roles played by vectors, not fixed dictionary definitions. The same token representation is transformed into these roles by learned parameters in a real transformer. Our synthetic toy model does not reproduce those learned parameters. It isolates the routing idea. Compare the query with every key, assign relative influence, then combine the values. That sequence is the mechanism we need to understand. Now the query meets every key through a dot product. A dot product compresses the alignment between 2 vectors into one compatibility score. Stronger alignment produces a larger score in this toy calculation, but a raw score is not yet a percentage and not yet the final amount of information mixed. Look at the bars as separate comparisons radiating from engine. They answer how compatible each key is with this query under this head's learned projections. They do not say what the model consciously noticed, because there is no consciousness in the calculation. They also do not stand alone. The scores still have to compete with one another before they can control a weighted information mix. Softmax transforms the score bars together. It makes every resulting weight positive and makes the weights share one total, so influence becomes relative. In this deterministic toy head, the temperature is 1.15. At temperature 1.15, quiet receives 63.5% of the weight, the largest share. That confirms the prediction that the descriptive token dominates this particular comparison. The strongest focus token is quiet. The remaining weight is spread across the other tokens rather than erased. Attention then multiplies each value representation by its weight and adds the results. The output is therefore a weighted sum of values, mostly influenced by quiet here, yet still containing smaller contributions from the rest of the sequence. Pause on the pipeline we have built. Query against keys, compatibility scores, softmax weights, then a weighted sum of values. The measured result is specific to this synthetic toy model, but the order of operations is the durable idea. What operation turns raw attention scores into positive relative weights? Softmax turns raw attention scores into positive relative weights that share the total. Notice what that answer does not claim. Softmax does not decide which tokens exist, invent the query, or explain why a full model produces an answer. It normalizes the current set of scores so they can act as relative coefficients in the value mixture. The clean bars are useful precisely because they leave many things out. Changing temperature reshapes how concentrated the weights are while keeping this score set fixed. That is a property of the displayed toy calculation, not evidence about every transformer. A deployed system contains learned query, key, and value projections, many heads, many layers, residual paths, and other operations that this picture omits. Even a large attention weight is an internal coefficient, not a guaranteed explanation of reasoning, intent, truth, or causation. So read the map narrowly. It shows how one synthetic head routes a weighted mixture. It does not show a mind choosing what to notice, and it does not summarize a complete model. Attention is a routing calculation. A query is compared with keys to produce compatibility scores. Softmax turns those scores into relative weights. The weights scale value representations, and the scaled values are added into a weighted information mix. In our synthetic toy model, engine is the query and quiet receives the strongest weight, but that measured example is only a teaching case. The mechanism is broader than the invented sentence. The result is not. Now transfer the idea. If the query changed, which part of the attention pipeline would you recompute first? Start with the query key comparisons, because new compatibility scores would flow into new weights and therefore a new mixture. That dependency is the durable intuition to take into the next transformer lesson.